Using the given graph of the function, find the following: the intercepts, the domain and range, intervals on which it is increasing, decreasing, or constant, and whether it's even, odd, or neither. So let's start with the intercepts. An x-intercept is where the graph crosses or touches the x-axis. So we have our x-axis here, and the graph touches the x-axis, crosses the x-axis, touches the x-axis in these places. So we have x-intercepts at -pi, 0, and pi. And we also have y-intercepts. A y-intercept is where the graph crosses or touches the y-axis. The y-axis is this vertical axis, and the graph does cross that y-axis at 0. So we do have a y-intercept at 0. Then we're going to find the domain and range and write that domain and range in interval notation. So when I find domain and range from a graph, I like to use a ruler or a pencil. And I'm going to hold my ruler vertically. And the reason why I'm holding it vertically is because my ruler is going to be going across that x scale, the x-axis, from left to right. So I'm looking for when is the first time my ruler hits the graph, and that's going to tell me the start of my domain. So the first time my vertical pencil or my vertical ruler hits the graph will be at -pi. So my domain starts at -pi. And then I want to decide if that point is included in the graph or not included. Because this one has a filled in dot at that point, it's included, and I'll use a bracket on that point. As I move my ruler from left to right, I can see that I'm continuing to hit the graph all along the way. So all of these x values will also be included in my domain until I get to this point. That's the last time my ruler will hit the graph. So my domain will stop at pi. And pi is also included in the domain. I'm going to do the same thing for the range, but I'm going to hold my ruler horizontally, going from bottom to top. So I'm holding it horizontally because my ruler will be going across that y scale. So for the range, the first time that my pencil hits the graph will be at this point right here, which has a y value of -3. So that's where my range will start. That point is on the graph, so I'll use a bracket to include that in the range. And as I continue from bottom to top, I can see that all of these y values are part of the graph. The last time I hit the graph will be at this y value of +3. So that's when my range will stop. That value is also included. The next part says to find intervals for which the graph is increasing, decreasing, or constant. So what I like to do with this is I like to trace the graph from left to right. As I'm tracing, I'm taking note of whether the y values are increasing or decreasing. So for starting the furthest left, my y values are decreasing. So let me make note of that. That's decreasing here. And then I'm going to change colors because at this value right here, the y values are now increasing as I trace from left to right. So let me label these as increasing. And then the y values are decreasing. And now I want to label the intervals, when they're asking for intervals, we're talking about the x intervals. So we want to see when this interval starts, which is at negative pi, and this interval stops, which is at negative pi over 2. And that will be an interval that is decreasing from negative pi to negative pi over 2. Then the next interval is increasing, and we've already seen that that starts at negative pi and that ends at pi over 2. So we can say that our graph is increasing, starting at negative pi over 2 to pi over 2. And this final interval started at pi over 2 and ends at pi, and we said that that interval is decreasing. So I'm going to add that on to this section here, pi over 2 to pi, and that interval is decreasing. Now some books will write the interval notation for these as negative pi with a bracket to negative pi over 2, union with pi over 2 to pi. And then for the increasing interval, you might write it as negative pi over 2 to pi over 2 with brackets instead of parentheses. So this is dependent on how the definition is worded for that particular book. So if you use the word open interval in the definition, you would write it this way with parentheses. And if you don't use the terminology open interval, you could include the endpoints as in this way of writing it. So pay attention to the convention that your book follows as to which way to write those intervals. Our final part, we want to determine whether this function is even, odd, or neither. Let me erase my markings and we can talk about what even, odd means. For a function to be even, it needs to have y-axis symmetry. So the y-axis is the vertical axis. And to have y-axis symmetry means that we need a mirror image on either side of that y-axis. So if we have a point on one side of the y-axis, we would have a mirror image of that point on the other side of the y-axis. So if we have xy, we would have a mirror of that point, negative xy, with the opposite x values but the same y values. You can see here I have this point pi over 2, 3, and I don't have a mirror image of that point over the y-axis, so we do not have even, this function is not even, and it doesn't have y-axis symmetry. For a function to be odd, you would have to have origin symmetry. So for origin symmetry, you want to have a mirror image over the origin where the x and y-axis cross each other. So for the origin symmetry, if you have a point, for instance xy, you would have a mirror image of that point across the origin. That point would have the opposite x value and the opposite y value. So looking at a few of these points, I've got pi over 2, 3. I have the opposite of that, which is negative pi over 2, negative 3. Opposite of both the x and y coordinates. I have the same thing with pi and negative pi. And as I'm looking at this piece of the graph, I have a mirror image of that over the origin in that opposite quadrant. So this function is an odd function. Thank you for checking out my videos. Have a great day.